Hello everyone! This is Dr. Meyer here with a video for you on how to visually identify written meter. That is, if there is no time signature. This video only concerns regular meter, where every beat has the same subdivision, so no asymmetrical or odd meters are being discussed in this video. Let's get started. As a quick refresh reminder, let's review what a time signature is. A time signature is placed at the beginning of a piece of music. This imposes a meter on the rhythmic surface. We use two types of regular meter, simple meter and compound meter. In simple meter, the top number tells you how many beats are in the measure, and the bottom number tells you the rhythmic duration of each beat. In compound meter, however, the numbers tell us a little bit different information. The top number tells us how many subdivided beats there are, and the bottom number tells us which rhythmic duration gets that subdivided beat. This fundamental difference between simple and compound meters is sometimes hard to suss out, especially when the meter isn't given to you. Take 2/4 and 6/8 meter signatures, for example. In 2/4, a simple meter with 2 beats of quarter notes, the beat of 2 quarter notes is clearly seen at the top of the rhythmic hierarchy, with the 8th note and 16th note divisions below. In 6/8, however, the meter signature is identifying the 8th note subdivision of 6 eighth notes and does not immediately indicate that there are only 2 dotted quarter notes in the measure of 6/8, in the same way that 2/4 indicates 2 beats. In simple meter, the beat is divided into 2 subdivisions. It's easy to see the hierarchy of rhythmic durations, as each iteration of the, quote, big beat, i.e. quarter notes, half notes, or eighth notes, at the top of each meter signature. This division is equally in 2. You can move up or down the hierarchy and assign a new big beat and keep the same subdivision. All simple meters have either 2, 3, or 4 as the top number. That's it. That's duple, triple, and quadruple. The duration of each beat is the bottom number, like half notes, quarter notes, eighth notes. Those are most common. Check out this chart for some simple meters that you have seen before. Remember, the top number will only ever be 2, 3, or 4 in regular simple meter, nothing else. Compound meter has a triple subdivision. That is, each beat is divided into 3 equal parts. The hierarchy of rhythmic durations is not as straightforward as we saw with simple meter, because only the first subdivision is divided into 3 parts, where further subdivisions are back to the equal 2-part division. An important aspect of compound meter is that the beat level will always be a dotted rhythm, as shown above. All compound meters have either 6, 9, or 12 for the top number. That is duple, triple, quadruple in compound meter. The duration of the beat is the bottom number, as you see, half notes, quarter notes, eighth notes, most commonly just like in simple meter. The bottom numbers don't change. Check out this chart for some common compound meters that you might know. Remember that the top number will only ever be 6, 9, or 12 for regular compound meters. That's it. Let's try to identify the meter of this measure together. One particular aspect about notation that we can use to our advantage is beaming. In standard notation, each beat must be isolated in order to preserve the meter. In this way, you should look for rhythms which are beamed together, as they will likely represent one single beat. In our example, we have 2 groups of 16th notes which have been beamed together. With this information, we can venture a guess based on our chart of rhythmic hierarchy. We know that 4 16ths equal 2 eighths, which equal 1 quarter note. From here, we can see if a quarter note beat will match the rest of the rhythms in the measure. You will have to decide whether you have 2, 3, or 4 beats, and whether the meter is simple or compound. So, based on the even division of our quarter note, we can say that we have a simple meter. But how many beats are there? 2, 3, or 4? Based on the beaming, we have 2 more groups which could potentially equal 1 quarter note. The eighth note chord and the eighth note rest make 1 quarter note, and the eighth note triplet also equals a quarter note. Quick side about triplets here. Take the rhythmic duration of the triplet and move up 1 spot on the hierarchy to find the full beat duration. So an eighth note triplet equals 1 quarter note. Similarly, a 16th note triplet equals an eighth note, and so on. Remember this to simplify triplets every time. Okay, we finally segmented out our measure, and we found 4 segments, which equal 1 quarter note each. What meter should we assign? 4/4. 4 beats of 4 quarter notes would have a simple quadruple meter of 4/4. Let's do another one together. Remember that beats will always be beamed together, and you can use that information to help. Here's one beat grouping that is immediately evident. It is a little complex, but if you take your time and break it down, you can see there are 3 eighth notes in this beat. We know that 3 eighth notes make 1 dotted half note. We can start searching for more beats of this value. So how can we do that without beamed groups? Importantly, ties will connect beats and keep them visually separate so as to not obscure the beat. This means any notes which are tied together do not belong to the same beat. We know that there are at least 2 beats in this rhythm group based on the presence of a tie. Looking for that dotted quarter note beat, we find 2 more beats in this measure. 1, 2. Adding up our beats, we see that we have 3 beats, which are subdivided into 3 parts. This means we have a compound meter, but which one? Triple compound. We have 9 eighth note subdivisions with 3 beats, so our meter is 9/8. Now it's your turn to practice. See if you can identify these meters by segmenting beamed groups and adding up the beats to sort out the best solution. Pause the video now if you need more time. For the top example, you should have found 3 complete beamed groups. When reduced, these beats all equal dotted quarter notes. The remaining rhythm also fits into 1 dotted quarter note value. So 4 beats of dotted quarter notes means you have a meter of 12/8. The bottom example is a little harder to sort out. You should have found 1 complete beam grouped at the end of the measure. This beaming reduces to 2 quarter notes, which reduces to a single half note. From here, we can search for more half note beats to determine the meter. You should have found 2 more half note beats. With 3 beats of equally divided half notes, you should have 3/2 as your meter. Hypothetically, could this measure also be considered 6/4? Well, the answer is no, because the beaming suggests here 3 separate beats. If it were to be notated in 6/4, there would have to be 2 dotted half note beats suggesting the beaming. But clearly there are 3 beats, so we have chosen 3/2 instead. Let's recap what we learned in this video. Meter signatures help to tell what meter is being imposed, but with discernment, we can sort that out visually without the signature. Recall that simple and compound meter numbers mean different things, and keeping them separate will help you discern the meter visually. To find the meter, use beaming to your advantage. Remember that beats will be isolated by traditional notation standards. Determine the number of beats using the remaining rhythms in the measure, keeping in mind subdivisions of simple and compound meters. Dotted rhythms are big beats in compound meter, whereas in simple meter, there's no dot. Don't overcomplicate the problem. You will only ever have 2, 3, or 4 in simple meter, or 6, 9, or 12 for compound meter on the top. The bottom number will always be a rhythmic value. Finally, don't make up a meter that you have never seen before. Check the charts. Make sure your answer makes sense as a meter. The simplest answer is usually the best. And we will practice more meter together in class, I promise. That's all for now. Thanks for watching.